Okay, let me give you guys some more practice. So given this function here, f equals blah 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 here, find the range of this function, and also find the domain of this function. Um, when given a function here, try to build up a picture inside your mind of what this graph will look like. Once you've got your graph, then you'll be able to answer the range and the domain. So for the first part, I will guide you through, and then later on I will ask you to press pause and have a go. But for the first bit, I will guide you through. So given this function here, remember there are so far, as far as we know, there are two no-nos. One is being a negative, a square root of a negative number. So, for example, what is the square root of -4? Well, you can't have a square root of a negative number. And the other no-no is 1 divided by 0. Whenever you have this situation here, the function here breaks down. Whenever you have this thing here, the function here breaks down. There are other no-nos, but for the time being, just remember that you cannot have a square root of a negative number, and you cannot have 1 over something equaling 0. Now, looking at this here, this bottom bubble here cannot be 0. The minute this bubble here is 0, then it breaks down. So, for example, you cannot put 3 into this thing. You cannot put -3 into this thing here, because the minute you put -3 into here, this whole bubble here will become 0. So you will have 1 over 0. It will break down when you put -3 in here. Okay, so the first step, hang on, oh yeah, the first step is try to visualize what this graph will look like. So hang on, normally we would create a table like this. Hang on, so here, rather than doing this, let me just show you a graph of 1 over x. You see, this table here is a table of 1 over x. So when you try and sketch 1 over x, it will look like this. Your y, your x here. 1 over x looks like this. Okay, it's a reciprocal graph. So when x is now this table here, looking at this table here only, the top table here, um, looking at this table here only, at the moment you've got y equals 1 over x. Okay, so if you put 0 into this x here, well, it breaks down. So we're just going to call it infinity for the time being. Now, if you put 1 when x equals 1, if you put 1 into here, 1 over x here will be 1. When x is 2, if you put 2 into here, it will be a half. If you put 3 into here, it will be a third, and so on. If you put -1 into here, it will be -1. If you put -2 into here, for example, 1 divided by -2, then you can see it's -1/2. Okay, and so on. Now, so this top table here represents y equals 1 over x. Okay. Now, looking at this table here, well, for us to try and understand this here, we first try to look at this table here. Now we are going to look at this one here. Okay, hang on. So hang on. Let me just. So this top table is y equals 1 over x. This bottom one, you can think of it as 1 over y. Y equals 1 over x plus 3. Okay. Now when x now you've got to put 0 into this x here. When you put 0 into the x, it will be the bottom bubble will be a third. Okay. So sorry, the bottom bubble will be 3. So in effect, you will have 1 over 3, which will be a third. Okay, but the thing is, look at this here. At the moment, the bottom table is 1 over x plus 3. When you put 0 into here, this whole thing here becomes 3. So it's just like up here, but with the number 3 at the bottom, meaning that when you put 0 into here, you are turning this bottom bubble into the number 3. When you put 0 into that thing there, the bottom bubble will become 3, meaning that meaning is similar to you stealing this thing here. It becomes this, so it becomes a third. Now let's look at 1. Hang on, you see what I mean later. So this here is a third. Now at the moment you've got y equals 1 over x plus 3. Now if you put 1 into here, this bottom bubble here will become a 4. That's just like you stealing this thing here and putting it down, putting it into here. So this here will be a quarter. Okay. Now if you hang on, at the moment you've got 1 over x 1 over x plus 3. Now if you put a 2 into here, then you in effect turn the bottom bubble into a 5. That's just like you stealing this 5 and take, well, that this here will be a fifth. Okay. And earlier if you look at this here, hang on, let me clear this. If you look at y equals 1 over x plus 3. Now if you put the number negative 3 into here, then this whole thing breaks down. So this here is like infinity here. So you see this bit gets, well, hang on, earlier was well, basically what's going on is this. Yeah, so 3 here will be hang on, sorry, let me think. Well, when x is 0 at the bottom here, when x is 0 here, this will be 3, so 3 gets mapped to here. So it's like you doing this here. What I'm trying to illustrate, it doesn't matter if you don't understand this bit. What I'm trying to illustrate is that a graph of y equals 1 over x, and then looking at a graph of y equals 1. Well, here what you've got here is this bubble here is similar to this one here. This graph here will look like this. You've got an asymptote right down when x equals 0. Remember, when you put 0 into this whole thing breaks down, so you cannot have a vertical 0. Okay, but then over here, it doesn't matter if you don't understand this bit. Over here, it breaks down when x equals negative 3. So this here, your asymptote will be negative 3 here. You can think of it as an invisible vertical line here, and your graph will actually look like this. Okay, hang on. Your graph will actually look like this. So it's just like everything being shifted across. Yeah. Well, it doesn't matter if you don't understand this bit. Well, what I'm trying to illustrate to you is that given that so here you've got f of x equals 1 over x plus 3 here, and the graph happens to be like this, negative 3 here, and then the graph happens to be like this. It doesn't reach 0, by the way. Okay, so here now, what I'm trying to illustrate to you is that when given this here, try to visualize the graph, and your graph looks like this. Your graph looks like this. Now from this, you should be it will help you find the domain, and it will help you find the range. Okay, so now press pause and have a go. What is the range of this function, and what is the domain of this function? So press pause and have a go. Okay, so to do this here, the domain is, remember, the domain is what you can put into this function without it breaking down. So it can be anything on this on the real number line except from the number negative 3. So you can say the domain is well, x belongs to anything on the real number line except from well, comma, and then you would say x cannot be negative 3. Okay, and the range here, well, the range, remember, the range is when it hits the y-axis. So here, it could be anything really. It will hit the y here. 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 It will hit the y here, except from 0. So here remember, when given this function here, you cannot find a value of x where this whole thing will be 0. Because even if you have 1 over, let's say, 999999999, this number won't be 0. It just won't be 0. So your range here your range would be this. Negative infinity, and then comma, infinity. So it's everything. It will hit everything except from. Now it doesn't matter if you don't understand this notation here. Except from this thing here. Except from one element, which is 0. Okay. So here this here is your range. Okay.